Welcome, everybody. We're going to spend quite a bit of time going through questions together for e-math. I want to see how it's going to be. Let's hope it's going to be fun. Preparing for the test tonight. So I'm going to go through questions and all the tutorials that you're expecting tonight. Let me just have a second look at tutorial 3. I'm going to just be solving all the questions. I'm going to give you the tools. And then I'm going to just start solving questions one by one by one. So there's something which I did record last night, but then because of the weakness in the Wi-Fi is a bit weak. So because of that, I can't share with you right now. So I may have to restart to show you what it is I was talking about. Okay. I'm just going to summarize. So for some of you, you already know that, especially those who attended last night. I'm just going to spend about, I don't know, 10 minutes, 15 minutes recapping things that everybody already knows, or that some people already know. And this is how you're going to start your test. I want to spend the first 10 minutes to whatever, 15 minutes talking about what you should do the moment you get into your test, okay? Giving you the tools that you're going to use and showing you the most important skill for this test. Then we're going to do all the questions because I want everything inside your head. I want you to have the summary inside your head, okay? So here I'm actually receiving a message. But yeah, I'm starting just for the sake of those that missed it, I'm going to restart a little bit and then go to questions that I know I'll start with the questions that I didn't do yesterday, okay? Then I'll start with those that I did yesterday in case for those who were there yesterday to also benefit. But I'm going to do the tables first, which is what you're going to do the moment you enter the test. So this is going to be your differentiation, okay? Let's talk about it. Let's talk about the whole of your differentiation for test 2, what it is that you need to know. And this is not just for test 2, this is for life. This is the whole of your differentiation. I beg you to bring me something which is different from what we're about to learn. What we're about to learn is exactly what you need for differentiation. So the moment you get into your test, I want you to make these, we call them 5 tables, okay? But we have 4 tables that are the same version. Then from there, we are going to have one more table that is going to be unique and different. So let me start by showing you the 4 tables that you have to know, okay? Let me start by showing you those 4 tables. So here it is. Table number 1, enter your test. You're going to say, we're starting. The moment you enter your test, you're going to make this table. So say y, then y prime, okay? This is you. You're going to say, this is going to be table number 1. Okay? This is table number 1. Let me make it a little bit thicker than what it is right now. So this is going to be table number 1, right? And right next to it, you're going to put table number 2, which is going to be, you can put 2 lines so that it doesn't clash with table 1. And then for table number 2, it's going to be the same thing, a little bit thick like this. This is going to be your y, then your y prime is thicker. So this is going to be table number 2. You have y, then you have y prime or dy dx. Okay, remember y prime is dy dx. Then table, put this the moment you enter. Right now, I'm telling you what you're going to do the moment you enter the test, and I'm also showing you what differentiation is. Okay, this is the whole thing. If you have this, you have everything you need. So you're going to put this table. This is going to be table number 3. So for table number 3, I'm going to have this. I'm going to put the y and the y prime. So this is going to be y. Then right next to it, I'm going to have y prime. Right? Then I'm going to have table number 4. Table number 4, let's cook, okay? All the questions, we must be able to do them with this. We must be able to do the questions in a flash, real quick. We must be able to solve the questions as fast as possible. This is now y and this is y prime. So I have my 4 tables. And in these 4 tables, guess what, my friends? In these 4 tables, that is where I'm going to put everything I need. Okay, then there's just a little bit more, which I'm going to put in table number 5. So let's put the things we need in these 4 tables. What is going to come in here is going to be the 6 trig functions. Sine x, please put them, please, Put them in the order I am giving you right now. You have to remember these tables or else you ain't started yet. When you get into your test, at the back of your paper, you're going to put these tables down. Cos x, then tan x, then sec x, then cot x, then cosec x. Put the 6 trig functions in this order. Then you put the derivative. The derivative of sine is cos. The derivative of cos is negative sine x. The derivative of tan, so tan and sec are related. And then cot and cosec are related. So if I say tan and sec are related, it means when you differentiate them, they give you each other. That's why you must put in this order. Tan is the stronger one. So he's going to give you sec, and because he's the stronger one, he will give you sec squared x. And sec will also give you tan, but it won't give you tan squared. It's the weak, and cot is the stronger one. He's going to give you cosec squared x. And cosec x is weaker. He will give you cot, but he will first come cosec x, then he will give you cot x. Okay? And now remember to make these last two to be both negative. Remember to make these last two negative. Very important. Right, now that you have made this one for trig, if you have made the one for trig, you are starting well. Now we are going to make for hyperbolic trig. It's copy paste. If you have the one for trig, then wow, this is good news. We do the hyperbolic trig one. The one for hyperbolic, we copy and paste. So we start with the y, okay, with the y's. So you have sine in this, you're now going to say sine hyperbolic x. You have cos, you're now going to say cos hyperbolic x. You have tan, you're now going to say tan hyperbolic x. You have sec, you're now going to say sec hyperbolic x. You have cot, you're now going to say cot hyperbolic x. You have cosec, you're now going to say cosec hyperbolic x. Don't rush, make sure you're good at this table, then, and don't make it harder than it is. It's a copy paste for whatever is coming now. This is copy and paste. So now I'm going to copy and paste the y primes as well, but I'm making them hyperbolic trig. And when you're copying and pasting, remember to ignore the signs for now. So ignore the signs, just copy and paste the things. So here is cos, I'll say here, cos hyperbolic of x. Then here is negative sign. Remember, don't take the sign, just say sine hyperbolic of x. Then sec, you say sec hyperbolic, then squared of x. Then sec x tan x, it is going to be sec hyperbolic x. Then tan hyperbolic x. Then cosec squared will be cosec hyperbolic squared x. Then this one is going to be cosec hyperbolic x. Then cot hyperbolic x. You see, after copying and pasting everything, then make the last three to be negative. Make the last three to be negative. So I don't want you trying to understand the hyperbolic trig. It's a copy paste. It's a copy paste of trig. Now let's put the other things which we need. Let's put the other things which we need. We have y and y prime. Let's put the other things which we need now. We're going to now the then cos inverse of x. Then we're going to say tan inverse of x. These are inverse trig. Then if I know inverse trig, I'm going to do inverse hyperbolic in. So sine hyperbolic inverse of x. Then here I'll do cos hyperbolic inverse of x. Then I'll do tan hyperbolic. So tan hyperbolic inverse of x. Make the tables. Make the tables. You have to know this now. How do I do for sine hyperbolic, cos hyperbolic, and tan hyperbolic? You should know that for the inverse trig, for table number 3, it starts with a 1. The denominator starts with a 1. Denominator starts with a 1, then it will do x squared. That is for table number 3. It is 1, then x squared. Okay, but for table number 4, it is going to be x squared in the denominator. Must split 1 over the square. It starts with a 1, so it'll be 1 then minus x squared. In here it is negative, then same thing, 1 over the square root of 1 minus x squared. Remember, it starts with a 1, and these two have a square root, don't forget. But for tan, never a root, so it'll be 1 over, and it starts with a 1 as well. Here it'll be 1 plus x squared, so tan is different. Tan is different, but remember, this is for the, let's do for the inverse hyperbolic trig. Guys, what I'm giving you is all you need. Okay, So now let's put, what else am I going to put now? Well, you're going to now put for the inverse hyperbolic trig, the very last table. For inverse hyperbolic trig, it makes more sense if you start from the bottom. It is 1 over the square root of x squared, but it's now plus 1. Okay, so this is going to be what it is. It's going to be just sine inverse is the one that is going to be different when we're dealing with the inverse hyperbolic trig. Do you see that? Now we keep going. Come on, come on, come on. We have this table. We are left with that's it's just start applying. So never in your lifetime and application of differentiating. Okay, you are going to be going to see the rules. Okay, you're either going to use the ideas from this table, or you're going to use the rules, or you're going to be using parametric or implicit. Then you are done. It's the whole differentiation. So I'm going to keep. Look at this. Here we have the four versions of this table, right? You put it down. The moment you enter your test, here's one more thing to put. This last table. Y then Y prime. Put this down. I'm going to show you how to use it. Here you are now going to put the last things you got to know, which is exponential function and logarithmic. So you should know the derivative of e to the x is just e to the x. Then you should know the derivative of a to the x. This is going to be a to the x ln a. A to the x ln a. Then we're going to have the derivative of ln x, the logarithmic functions now. This is 1 over x. Then you should know the derivative of log base a of x. This is now going to be 1 over x ln a. This is going to be what it is, and we are done. I'm sorry for saying back. Give me a sec. All right, our table is going to end here. Oh, come on. Our table is going to end here, guys. Let me click on the pen. Our table is ending here, and we are done with the table. So this is part number 1. You have to reproduce this table the moment you walk into your test. We're going to use it for all the questions. We'll be doing them right below this table. This table is carrying us. Now, if you know this table, then the next thing you must know is the 3 rules of differentiation. You should know the 3 rules. What are those? The 3 rules. You should know the product rule, you should know the quotient rule, and you should know the chain rule. Deep. Let's put going to be what? If I know this, because what I'm giving you right now is the picture of differentiation. Where does it start and where does it finish? I'm going to show you. And the rest is just application, people. The rest is application. You'd be done with differentiation itself. Put this table when you get in. If you got in after I had already done the table, move the video back. Now, when you know this table, when you say, okay, I know everything in this table, I'm good with it. We say, are you sure? You say yes. We say, are you really sure? You say yes. Then we're going to say, okay, now you must know how to differentiate them when they are combined. When you have two friends multiplying, like you have, you've been dealing with cos inverse. You know how to do it on its own. What about if we say to you, can you please differentiate ln x sine inverse of x? Please differentiate this, okay? Ln x, then sine inverse of x. Ln x and sine inverse are multiplying. You're now going to need to know. You know how to differentiate ln on its own. You know how to differentiate sine inverse on its own. You have it in the table. But now you have the multiplying. What do? You use the product rule. So here's an example. So let's put the product rule and let's quickly do. So you now need to know the rules. Number 1, it's for rules are for when the functions are combining, either multiplying each other or dividing each other or one inside another. So let's start with the product rule, okay? Product rule, yes. Do I need them? Yes, you definitely do after knowing this table. Just know that the product rule says if you have yb equal to uv, we will always find the u and the v. When we get a question, come on, we must do all questions without coming back to the rules. I don't want to teach you anything in a question. It's practice. In questions, you must have all the knowledge you need. So that is why I'm making y prime. So you're going to say if y is equal to this, then then your derivative, your y prime, is going to be the product rule says, bring the second function, which is v, multiply by the derivative of the first u prime, plus bring the first function u, multiply by derivative of the second v prime. Okay, an example of y being equal to uv, we say, e.g., if you have x squared ln x. Here you have two functions multiplying, so you're going to use this. Okay, your u will be x squared. Even if it was 3x squared ln x, this 3 would not matter. You'd say u is the x squared, then v is the ln x. Okay, because this 3 would not go anywhere. It's multiplying, it will never go anywhere. All right, so here we got it. We got the y prime. So if y is this, then you must know that y prime will be this. Second times derivative of the first plus first times derivative of the second. It's illegal. It's actually a crime to forget this. It's a crime, straight up. The next thing you got to know is the quotient rule. So the next thing I have to know is the quotient rule. Right. Quotient rule, yes. Are you sure? I'm 100% sure, mate. Okay, what does it say? It now says if you have y being equal to u over v, two functions dividing. For example, e.g., you have x squared or 4x squared, you have 4x squared over sine x. You have two functions dividing, mate. Now, for you to get your derivative, you'd say then, you must know that, you say then y prime will be equal to, what you must know is that when we're doing quotient rule, we use a mnemonic. This is going to be the u is the high, then v is the low. You must know that. When you are differentiating fractions, we say this, low d high, we usually, low, which is v, d high is the derivative of the top, because high is the top, vu, minus high, which is u, d low, the derivative of the bottom, all over square the bottom, so over v squared. This is what you do, okay? It's low d high minus high d low over square the bottom. You must remember that, okay? Low d high minus high d low over square the bottom. This will give me my quotient rule. This will give me my quotient rule. Remember, it is when it's like this. It's not when you have 4 over sine x. No, this is not quotient rule. Now let's go to the third, the rule number 3. I don't know why I called quotient rule number 2. Everywhere, this is going to be the chain rule, okay? Chain rule. All right, so chain rule, yes. Are you sure? Yes. What is the chain rule and what does it say? Okay, I'm going to teach you the situations. I'll give you many examples. But chain rule says you should just differentiate outside. Okay, differentiate the outside without changing the inside. So differentiate the outside without changing the inside. So you're going to differentiate the outside without changing the inside. Then what do? You say then multiply by the derivative. Multiply by the derivative of the inside. Okay? Then multiply by the derivative of the inside. So this is important. Hey, if you want to pass, know this chain rule. Let me show you why. Let me show you where you use it. Remember, the first thing I taught you is the table. You must know how to use the chain rule, because guess what? In the table, we do the functions themselves, but we do them when they are basic. We do sine x, cos x, tan x, sec of x, cot of x, sine hyperbolic of x, cos hyperbolic of x, sine inverse of x, cos inverse of x, tan inverse of x. But in a question, we never get it to be tan inverse of x. It could be tan inverse of something which is not x. They could give you tan inverse of x squared plus 5, and they still want the derivative. So things are changing because you're now having tan inverse of something which is not an x. This is the situation where we use the chain rule. Master the chain rule with me right now in the next 3 or 4 questions to do only this and chain rule, and you have to be able to do it. You have to. Let's start to do questions where I use it. When do I need to use the chain rule? Let's talk about chain rule. Let's master chain rule, then we can start questions. Let's master him. What is the chain rule and what do I need it for? Chain rule, you're going to need it for the table, but you're going to be applying when you have it, what we call composite functions. So guys, this is what you always almost get. I can promise you right now, you're going to see when we do all questions, the past paper ones, the tutorial ones, whatever the question, it's going to be 9 times out of 10 a composite function. They'll give you sine, but they won't give you sine of x. They'll say differentiate sine of 4x, or differentiate sine of ln x, or differentiate sine of whatever, but it's not nx. So whenever we get a function and the thing inside it is not x, it's something which is not x. When we have a situation like that, we say we have a composite function. And to differentiate it, we are going to use the chain rule. And the chain rule says differentiate the outside without changing the inside. You hear me? It says differentiate the outside without changing the inside. Then multiply by the derivative of the inside. We will then multiply by the derivative. So when we start with the outside, you are going to use that in place of x. Let's see, for example, sine x, we are not scared of it. But here, the moment I see something which is not x, remember that is a composite function. And you're going to need to use the chain rule. And that is going to be there in all tutorials. You're going to see it again and again and again. Because differentiation is the table, product rule, quotient rule, chain rule. That's differentiation, okay? If you know that, you know differentiation, mister. You just need to know parametric and implicit. Then we say you are done. You are done. The rest is now application. You are now applying. You're going to find the derivative using the table or these things which I'm showing you. And then you are going to apply it in some way to find the turning point. Apply it in some way to find the rate of change. Apply it in some way to find the gradient. Apply it in some way to find the nth derivative. Apply it in some way to use Leibniz. But you'll be using differentiations of these things. These skills. So don't mix up differentiation itself and applications. Most of those questions are applications. If you know differentiation, which you must, you can't fail to differentiate. It's a crime. It's a crime. This is a small thing. Then you should be able to then apply it in whatever question now. You should know how to find turning points. What do you do with the derivative? You must know, okay, so now that I found the derivative using the table, what do I do with it? So let's see how to differentiate this. You have y being equal to this. Now you want to find y prime, or you want to find dy dx. How do I find it? I am differentiating sine of something which is not an x. So the moment I see this, you say this is a composite function. My friends, if you're able to see this for all composite functions, you are a good differentiation student. So you're going to say, ooh. For me to do it, I start with the outside. Chain rule says differentiate the outside without changing the inside. What's the derivative of sine? You go to the table. The derivative of sine is cos. We're differentiating sine of x, we got cos of x. It's sine of ln x. So when we differentiate sine, what do we get? Cos. We start with differentiating the outside. So this is going to be cos. Does the inside change? No. You just differentiate the outside, keeping the inside as it is. Then you multiply by the derivative of the inside. You then now multiply by the derivative of the inside. The derivative of ln x is now 1 over x. So this will become cos ln x divided by x, because we are multiplying by 1 over x. So this will be the solution, and you are done. Oh my goodness. You gotta be able to do this. Let's do another one. Let's do another form. Let's say I'm giving you an easier one. I'm going to be making harder and harder ones. We're going to do 4 questions on chain rule. 4 questions of 5, and we are done with the chain rule. I will be saying you have mastered it. I'll be proud. What about if I have something like this? Let's start with saying e to the 4x squared plus 5x. And we want to get the derivative. You start e, that's the outside. You go to the table. What is the derivative of e to the x? It is e to the x. So it comes back as it is. It comes back as it is. So here we have e to the 4x squared plus 5x. For our derivative, for our dy dx, we bring it back as it is. It's e to the 4x squared plus 5x. Okay, we bring it back as it is. Then we multiply. So we have differentiated the outside. Remember, you differentiate the outside first without changing the inside. So we have differentiated e using the table, and the derivative of e is it comes back. Then now we multiply by the derivative of the inside, which is the derivative of 4x squared plus whatever. So the derivative of 4x to the power of 1. Okay, so this is what we have. So we will now just say this is going to be the exact same thing. So you can say 8x plus 5 multiplying e to the 4x squared plus 5x. This is exactly what it is. Here is the derivative. This is the chain rule. Chain rule you apply to composite functions. Hey, come on. Don't make a mistake here. This is the type you are going to get. I promise you. Look at this. Let's do a harder one. Let's do the third example. What if I have it this o to the power of 7? Okay, this is my y. Is this a composite function? Yes, it's a composite function. You say to me, what are you talking about, mister? What are you talking about? If it was y is 4x squared plus 5x, this would not be a composite function. This is a normal one. But what is this power of 7 doing? It's multiplying. Everyone, look at it, what it's doing. It's outside multiplying everything. So it makes it a composite function. When you see something like this, this is a composite function. People, this is a composite function. So how do we differentiate this composite function? We start by differentiating the outside. It's the chain rule. We do the chain rule, man. Can you guys hear me? Hello? Say yes in the chat if you can hear me. Say yes in the chat if you can hear me. Can you hear me? Say yes in the chat. If you can hear me, say yes in the chat. All right. No, I'm going to do tutorials. Don't worry about it. I'm going to do all the tutorials real quick. Don't worry about it, man. I got you on that. I'm going to do all the tutorials at supersonic speed, and it will be unacceptable for you not to get a question right, because you now will be knowing this. You know this, right? So I'm starting now. I'm starting now. Don't worry about it. I'm starting to do tutorials exactly now. Tumo, look at this. So what we're just saying is to close this up. We're almost done. Tumo. We're almost done. Within 5 minutes or 10 minutes, I'll be done, and then we'll be starting our questions. Many questions, non-stop questions. You're gonna do so many questions until you don't want to do them. Don't worry about it. So you're going to be doing questions together. So look at this. How do we differentiate it now? This is going to be chain rule, because you have a function inside and another one outside. Don't fail to do it. If you fail to do it, you are throwing away marks. Look, you're going to now say, okay, dy dx is going to be equal to, remember, what is the chain rule? Start with the outside without changing the inside. So for the outside, this is a power. You drop it, 7, you reduce it by 1. Don't change the inside. It is still 4x plus 5x. It is now to the power of 6. You drop the power and reduce it by 1. You start with the outside. Then you multiply by derivative of the inside. What's the derivative of 4x squared? You drop the power, it becomes 4 times 2, that's 8, x to the 1. Plus the derivative of 5x is just 5. So this is what we'll be having. And we'll actually have 7 multiplying 8x plus 5. And this is multiplying 4x squared plus 5x to the power of 6. This is what you have. This is your derivative. That's how you get it. Even if you got something like this, y is equal to the square root of x squared minus 7x. What do? You can't differentiate roots. So you're going to change it to say y is equal to x squared minus 7x to the power half. Okay? Square root is to the power half. Once it's in this form, we can see the chain rule. Once it's in this form, we can see the chain rule. The chain rule will say to you, start with the outside. Differentiate the outside, then multiply by the derivative of the inside. So you start with this half, you drop it, so you can say your y prime is going to be half, comes down. Then the inside doesn't change, x minus 7x. It is now to the power negative half. Okay, you drop the power and reduce it by 1. Then you now multiply by the derivative of the inside, which is 2x minus 7. Okay. What if it was 2x x squared minus 7 only? Then the derivative of the inside will be 2x. You see? Then now we're just going to simplify this. The 2 and the half will cancel. Then you're going to have your y prime being equal to x squared minus 7 to the power of negative half times x, which is going to be equal to, you can now say your y prime will be actually x all over x squared minus 7 to the power of positive half, because it's now in the denominator. And something when it's the power of half, it's the root, so it's going to be x over the square root of x squared minus 7. Okay, sorry, there's a ringtone, so sorry for that. Okay, yes, and then this is what happens. Okay, x over the square root. This is going to be your y prime. This is going to be your derivative, your dy dx, your y prime. And you have your y. This is how you use the chain rule. Let's just do one more for go to. You're getting ready. You are seeing the chain. Y is, say, x squared plus 5. Let's say that. And we want to differentiate this creature. We have this devil. Ladies and gentlemen, boys and girls, you can see not x. In my table, I have sine inverse of it's sine inverse of something which is not x. You go to the same table which I gave you at the beginning, but you're going to use it to differentiate the outside. Remember, the inside will not change. So let's start by differentiating the outside. Well, first of all, before we start, we can simplify this inside. We can't differentiate this root, so we got to change it. So it's going to be y is equal to sine inverse. Then inside should become x squared plus 5 to the power half. Okay, this is what we're getting sine inverse of. Are you ready? Yes. Let's go to the chart now. We want to differentiate this. Where do we start? The outside. You differentiate the outside, which is sine inverse. You start by differentiating the outside without changing the inside. So let's differentiate sine inverse. The derivative of sine inverse of x, you know what that is. It is 1 over 1 minus x squared, the square root of. Now here we don't have x because that was for sine inverse of x. Here we have sine inverse of something which is not x. So in place of x, we are now putting this. So that means our y prime will be 1 over the square root of 1 minus, instead of x squared, because x squared was in when it was sine inverse of x. Now it is sine inverse of this. So it is 1 over 1 minus this squared. So it'll be 1 minus x squared plus 5 to the power of half, all squared. This is 1 over 1, it is 1 minus this, which is going to be our y prime is going to be 1 over 1 minus. Now what do we do? This power of half and this squared will cancel. So it'll be 1 over 1 minus x squared plus 5. This is your y prime. And you just remember, I have done a big thing here. Remember to then multiply by the derivative of the inside. We started with outside very well, but we didn't finish. We should then multiply by the derivative of we've done the derivative of sine inverse, but now we should multiply by the derivative of the inside. The derivative of the inside is the derivative of this thing, which is another composite thing. When we're getting the derivative of this, what do? You drop the power. You start by the outside of the inside, which is the power half. You drop the power, then reduce it by 1. X squared plus 5 is now to the negative half. Then times, you then multiply by the derivative of the inside, which is just 2x. This is what you do. So this is going to be now times, here it's half times 2, which is now going to be 1 over x squared plus 5 is now to the positive half then times an x. Okay, now let's simplify this. We're going to have y prime be equal to 1 all over 1 plus 5 is 6, so 6 minus x squared, then times 1 over the square root of x squared plus 5 times x, which is what we're going to put. So it's going to be equal to 1 all over, it's x, because x is a whole number, it multiplies the top, all over 6 minus x squared, and then all over the square root of x squared plus going to be your y prime. Do you see this? Chain rule. If you're not good at this, it's the chain rule which is causing you problems. It's the chain rule. If you have this table, you should have this table, and this table will help you to differentiate. The chain rule. Remember to come and put it. So that is what you must know. Differentiation. Yes. Yes, yes, yes. If you know the product rule and you questions from tutorial 1 all the way to 6, whatever, which will ask for differentiation itself, we should be able to answer them in a fashion. It's like I have 2 questions now. Can you all hear me? Type yes in the chat if you can hear me. I need to confirm. Please type yes in the chat if you can hear me. Type yes in the chat. Okay, good. This will be the chain rule. I don't know what you heard and what you didn't. I was just talking to myself probably. Did you hear me say everything, Tumo? Did you see me do this whole question? This whole last question? Tumo? Why is the chat not active? Guys, did you see me do this question? You see me do it? Tumo? Did people see me do this whole question? Okay, good. This is going to be it. You're done. Ladies and gentlemen, if you're good at this, you're good at the chain rule. It's must. Okay, you said, Mr. Chain Rule, I now know you. So let's remove. Let's now go to questions. Let's go to questions. Doing of question. I want to do them really quick. We are just left with parametric and implicit and practicing. Let's go and do a lot of differentiation questions. We want to differentiate and differentiate and differentiate and differentiate and differentiate. Okay? Want to differentiate and differentiate and differentiate and differentiate. Very important. All right. Now we have 2 more things to know. For you to say you're done with differentiation, you will need to know, yes, I'm going to tutorials to do that. Parametric and implicit. Let's go to the tutorial questions. These are the last 2 things, and you now have the whole of differentiation. The rest is not differentiation, it's application. So this is differentiation. Let me scroll up. This is differentiation, ladies and gentlemen, boys and girls. Prove to me that there is anything in differentiation which is not on this list. Okay? If you can prove to me, come get your debonaise. Of course, I would never challenge you to that because I don't want to buy debonaise. I know you will never have anything else. This is differentiation. This and implicit and parametric. Mathematician, you know how to differentiate. Let's go to the tutorials. Let's do parametric and implicit. Those are the things we are left with. So I'm going to open that tutorial. Let's start doing it. I don't know if it's tutorial 3 or 4, whatever. I'll start with open tutorial. Okay, Tomo, Rose theorem and mean value theorem will do them. I don't know if Rose theorem is coming. I never saw a question in any of your tutorials, Rose, asking about Rose theorem. I know about mean value theorem. Okay, this thing is extreme. Okay. This is a disaster. Let me see if I can do it another way. Okay, let me go open them. I think it starts in tutorial 3. Let's just do the questions as fast as we can. Okay. Is the quality bad? Is the quality bad? Um, is the quality still bad? Can you see this? Okay. Base, okay? We give me these next few minutes till 12 after 12. Let me change bases and then I'm going to go live again.